Let me remind you what the overall goal is. So here I'm showing predicted values, not true values, from our logistic regression classifier. And I want to know, what does the decision boundary look like? Like, where does the classifier switch from predicting Adelie penguin to predicting chinstrap penguin? Like, is it around here? Is it around here? And so on. And so what I want to do is I want to replace these true values here of bill length and bill depth. I want to replace them with artificial values. And I'll do this using, say, the DFSim2 up here. And so that DFSim2, it's going to have many more points. It's going to be a much more dense grid of points. And then we're going to color those using the classifier, using the logistic regression classifier. So, okay, let's go ahead and try this. So DFSim2, and the only reason I'm using this one is because it already has the correct column names that I want to use. And so let me do clf.predict. And so what this is going to do is it's going to say, if there's some hypothetical penguin with 32 bill length and 13 bill depth, what is the predicted species of penguin by our classifier? Okay, and I'm going to save this inside this same data frame in the column name called pred. Okay, great. And now I should pretty much be able to just copy this code, I think. And let's see. I think all I should have to do is change this. Unfortunately, there's going to be a slight error. Let me show you. So I have slightly too many points because I'm just plugging in too many points here. And so I could, like, it's not so bad. Like if I look at the length. Okay, so it's not off by too much. So I could pretty easily just go in and change the maximum number. Okay, you can see some previous notebook for how to do that. But instead, I want to show you a different method, which is using a data frame method called sample. So let me call it dfsim2 sub for sub data frame equals dfsim2.sample 5,000. And what this is going to do is it's going to take 5,000 random rows out of the data frame. Okay, and let me check this, dfsim2 sub. And you can see it also mixes up the order, but that's fine, doesn't matter for us. In some ways, this is actually nicer because you can see all three species of penguins here. Unlike if it was in the original order, then it would be all the same species at the beginning, because those are all very similar in measurements when it's not randomized. And so what was the point of this? Well, you can already see it here, this 5,000. The point is that this dfsim2 sub now has only 5,000 rows. And we got that using this sample method. And so let's replace this here with sub. And remember how we talked about and we proved in the binary case that it's a linear decision boundary? Here you can see that it's also very much a linear decision boundary. And you can see it's not like perfectly filled in with points because there are only 5,000 out of the 6,300 points. So there are some little missing spots, but this is still enough information to like clearly see that it's that they're linear decision boundaries.